Hey, what's up everyone, and welcome back to another session with us here at Dr. Coolcat. So glad you're here. Today, we're going to tackle something that I promise you will see on the GED Science test, balancing chemical equations.
Okay, let's just dive right in. When you see something like this pop up on the screen, does your brain kind of just shut down? Yeah, I totally get it. It looks like some kind of foreign language or a secret code, right? But stick with me because I promise, by the end of this quick explainer, this is all going to make perfect sense. You'll know exactly what to do.
So here's our game plan. First, we'll look at these things as just simple recipes. Then we'll decode the numbers, go over the one big rule, learn a super easy tally method, and then we'll put it all to the test. Simple as that.
All right, let's get started. Part 1. What in the world is a chemical equation anyway?
You know, it sounds super complicated, but it's really not. The best way to think about it is like a recipe for baking. Seriously, it's just a chemist's shorthand for what's happening in a reaction. You've got your ingredients, we call those reactants, and then you've got what you end up making. We call those products.
So look at it this way. Everything to the left of that little arrow, those are your ingredients, your reactants. The arrow itself just means makes or yields. And then, bam, on the right side, you've got your finished product. So in this famous example here, you take some hydrogen, you mix it with some oxygen, and what do you get? You get water. Simple, right?
Okay, so we've got the recipe idea down, but what about all those little numbers and big numbers floating around? Well, that is the secret to cracking this code. Let's decode them.
All right, listen up, because this is probably the most important part. There are two kinds of numbers here, and you've got to know the difference. First, you have the subscripts. Those are the little tiny numbers. They tell you how many atoms are inside one molecule. So H2O means 2 hydrogens. And here's the golden rule. You can never change the subscripts, ever. If you change them, you've made a completely different thing. Then you've got the coefficients. Those are the big numbers out in front. They just tell you how many of the whole molecule you're working with. So 2H2O means you have 2 entire water molecules. And these are the only numbers you're allowed to change. Got it? Only the big numbers.
So that brings up a good question. Why do we even have to balance these things in the first place? What's the point? Well, it all boils down to one of the biggest rules in all of science. It's called the law of conservation of mass. And all it says is, you can't just make stuff appear out of thin air, and you can't make it disappear into nothing. It's that simple. So whatever atoms you start with, your ingredients, you have to end up with the exact same number of those atoms in your final product. Nothing gets lost along the way.
Okay, so how do we actually do that? How do we make sure everything lines up perfectly? I'm going to show you a super simple step-by-step strategy. We call it the tally method. And honestly, this is going to be your secret weapon for the GED test.
It's just a 4-step checklist. Super easy to remember. Step 1, make a list, an inventory of all the atoms you have on both sides. Step 2, find the ugliest, most complicated-looking molecule and start there. It sounds weird, but it works. Step 3, start plugging in those big numbers, the coefficients, to try and make the counts match. And step 4, it's a little bit of back and forth. You adjust one side, check the other, and keep tweaking until it's all perfectly balanced. Okay, enough with the theory. Let's get our hands dirty and actually try this out on a real GED-style question. Time to put the tally method to work.
So here's our challenge. We've got iron plus oxygen, and it makes iron oxide, rust, but it's not balanced. The question is, which of these sets of coefficients, A, B, C, or D, is the right one to balance it out? Just take a second, look at it, what's your gut feeling? All right, let's fire up the tally method. Step 1, the inventory. On the left side, the reactants, let's see, we've got 1 iron atom and 2 oxygen atoms. Okay. Now on the right side, the products, we have 2 iron atoms and 3 oxygen atoms. Yeah, you can see right away the numbers are all over the place. Totally unbalanced.
So where do we begin? Well, that oxygen looks like the tricky part, right? You've got 2 on one side and 3 on the other. That's kind of awkward. So here's a pro tip. When you have a situation like that, find the smallest number that both 2 and 3 go into, the lowest common multiple. In this case, it's 6. So our goal is to get 6 oxygen atoms on both sides of the arrow.
Okay, so how do we get to 6? On the left, we need to put a big 3 in front of the O2. 3 times 2 is 6, boom. On the right, we'll put a big 2 in front of the Fe2O3. 2 times 3 is 6. Awesome, the oxygen is balanced. But wait, look what happened. By putting that 2 on the right, we also changed the iron. We now have 2 times 2, which is 4 iron atoms on the product side.
We are so close. The oxygen is perfect.
We just have 1 iron on the left and 4 on the right. That is a super easy fix. All we have to do is slap a big 4 coefficient in front of the iron on the left side. And now, let's do our final check. 4 irons on the left, 4 on the right. 6 oxygens on the left, 6 on the right. We did it. It's perfectly balanced.
So, the magic numbers, the coefficients we needed, are 4, 3, and 2, which means the correct answer is C. See? I told you, it's not some impossible secret code. It's just a little puzzle, and you totally just solved it.
Seriously, that was awesome. Now, I'm genuinely curious about something. Go back to before we started solving it. What was your first guess? Which answer just looked right to you? Drop a comment below and let me know if you picked A, B, C, or D, and maybe why you thought that. There's no judgment here at all. It's super interesting to see how we all think through these things.
Just remember, the more you practice this, the easier it gets. But now you have the tool. You have the tally method. You've totally got this. Keep it up, and you're going to crush this part of the GED.
Hey, if this little guide helped you crack the code, do us a huge favor and hit that like button. And definitely subscribe to Dr. Coolcat so you don't miss out on any more tips to help you ace that test. Thanks so much for hanging out and learning with us today.